Rational functions, review sheet F2, finding stationary points. Question 1. First of all, we're asked to sketch the graph of y equals 3x minus 6 over x brackets x plus 6. So first of all, we look to find all the clues we can before we go to do the sketch. And so first off, we find the intercepts. So at y equals 0, we're basically solving 0 equals 3x minus 6. Notice the bottom doesn't matter because if I times it up by 0, then it's going to disappear. So effectively this can be rewritten as x equals 6 over 3 equals 2. Notice there's a point it goes through, so let's write it down as a point 2, 0. Next, let's look for the intercepts on the y-axis, or the x equals 0 line. So we put in x equals 0. And here we note that y equals 3 times 0 minus 6 over 0 brackets 0 plus 6. And here we have a problem because effectively we're going to have on top 0 times 3 minus 6 is minus 6. And on the bottom we've got 0 times 0 plus 6, which is 0. And so 6 divided by 0 is impossible, so there's no solution. And we'd like to know that, so it means effectively we do not intersect the y-axis. We do not intersect the y-axis. There's no solution to x equals 0. Next thing we're going to look for is the vertical asymptotes. So we'll go vertical asymptotes. So we're looking for the vertical asymptotes. And here, go back to the original question, we're solving for the denominator, or the bottom of the fraction, equals 0. So we're solving, in effect, to look for the vertical asymptotes, we're solving x brackets x plus 6 equals 0. Two solutions, x equals 0 and x equals minus 6. Okay. Next thing we're going to look for, so we found the intercepts, we found the vertical asymptotes, we'll find a horizontal asymptote. So find our horizontal asymptote. And here, to find a horizontal asymptote, we're looking at what happens as x tends to plus or minus infinity. So we've got y equals 3x minus 6 over brackets x plus 6. So looking at this whole expression, we can see it's a proper fraction because the highest power of x on the top is 1 and the highest power of x on the bottom is x squared. So there's a higher power of x on the bottom than on top, so making it a proper fraction. That means as x tends to a large value, as x tends to say plus infinity, the bottom is going to become much larger than the top. So y will tend to 0. So we already know by just looking at this fraction, because it's a proper fraction, that the horizontal asymptote is y equals 0. But let's look at two ways we can make sure of that point. Firstly, we look at the highest power of x, x squared, and we can divide top and bottom by x squared. Notice we've got two terms here on the top, and we've got two factors on the bottom, x times x plus 6. So let's first of all divide the top by x squared. So 3x divided by x squared would give me 3 over x minus 6 over x squared. Now divide the bottom by x squared. Well, x divided by x is just 1 plus, and now divide this term, this factor by x, we're going to get 1 plus 6 over x. So as x tends to plus infinity, y tends to, and if we look closely here, we're going to see as x gets large, these two terms both tend to 0, but this one will be larger because this number will be larger on the bottom, so this term will be smaller. So we have a bigger positive term. On the bottom, we'll have 1 times 1 plus effectively 0, so it will tend to 1 on the bottom and tend to a small positive value on top. So we'll tend to 0, but from above 0. Similarly, if we say as x tends to minus infinity, y will tend to, and again, if we tend to minus infinity, well, this term will be negative. This term will still be negative because negative infinity squared will be a positive value. So we'll have a negative value on the top. We'll have 1 times 1 plus a very small negative value here, so it'll be effectively 1 on the bottom with a negative value on top. So y will tend to 0, but from below 0, a small negative value. If we're unsure about this approach, or we just want to make absolutely sure, we can go back to our original expression, and using our calculator, the silver calculator, we can put that expression, that rational function, directly into the calculator. So we'll say alpha y, alpha equals, note the use of alpha equals, fraction button, 3 alpha x to get the x symbol, minus 6 over alpha x, open brackets, alpha x plus 6, close brackets. So it looks identical. Our two expressions look identical. And then we can evaluate this or calculate it for different values of x. So let's calculate it for when x tends to plus infinity. Well, plus infinity, as far as we're concerned, let's call it 1000. You know, we can make it bigger if we want, but just to see what happens to y as x gets big. As x gets big, say 1000 in this case, y tends to 2.97 times 10 to the minus 3. Note carefully that times 10 to the minus 3. So it's a very small positive value, i.e. y tends to 0, but from slightly above 0. So we say put a little plus there to know it's 10 to 0 from above. And similarly, if we calculate it for a large negative value, in this case I'm going to say minus 1000 equals, and we see again we get a negative value, but it's a very small value, times 10 to the minus 3. So we're tending to 0, but from below 0. We've now got all our clues, so let's put our clues onto a sketch. So draw our axes, and we put on all our clues. Firstly, the only intercept we've got is 2, 0, so let's put that on. I'd like to put a cross there, so it's clear we can cross at that point, or we must cross at that point. There was no intercept on the y-axis, or the x equals 0 line, so we've got no intercept on this line here, so we don't cross this line at all. We've got two vertical asymptotes at x equals 0 and x equals minus 6, so let's put those on. X equals 0 and x equals minus 6. Let me clear it. I'll put a 0 there so we've got to clear it's the axis. Here's the y-axis, here's the x-axis. Any other information we got? Oh, we've got a horizontal asymptote at y equals 0. So at y equals 0, just along the x-axis, we've got a horizontal asymptote there. And we know, as x tends to a really large value, y tends to 0 from above. So we're tending from above, so it's sort of coming from above here. And when we go to a large negative value, it tends to 0 from below. So we'll put a little bit of a line in there. So we've got those all our clues that we've worked out, we've got on our sketch. And now we've got to follow our lead. Now, we know it has to go through this point, and we know we've got to tend to this vertical asymptote. So we've got no choice but to come down through that crossing point and bend down to that line. Similarly, as we go across the line, the sign of the function will change. And in this case, it will go from being negative to positive. So it makes sense that we're going to come down from this asymptote above. So we're coming down from the asymptote above here. Now there's no crossing of this line here. We haven't got a crossing point. The only place we can cross the line is at this point here. So we must bend back round and tend to this second vertical asymptote. And notice we do not cross the x-axis in between. And this makes sense because we change sign as we go across the asymptote. So here we are coming up from the other side of the asymptote and coming up and meeting the curve here. And that's our full sketch. That through so you can see it.